Okay, so hello everyone, welcome to Power Electronics lecture number 12A. So the first topic which we are going to cover is single phase full wave control rectifier with RLE loop. Write down the main heading. Single phase full wave control rectifier with RLE load. So last two lectures we have discussed RL load. Same configuration with RL load. So quickly draw the configuration. So over here we have T1 and T2 are simultaneously triggered at omega t equal to alpha, and T3 and T4 are the pair of SCRs which are simultaneously triggered after pi radius, that is pi plus alpha. Input is a single phase AC. I in is the source current, input current. I out is the load current or the output current. Now over here, RLE, E stands for a voltage E or a battery. It's maybe due to a battery in a load circuit, or maybe a generated EMF of a DC motor. So now we are going to analyze this circuit and probably draw the waveforms for input gate pulses, then the input source current, output voltage, and probably voltage across the SCR, right? That is what we have been doing this so far. So we have discussed with RL load. The functionality of in continuous mode operation is same as RL load. No difference in the waveform. Let's see how it is. Yeah, there are two important statements which we have to write. Do you understand what do you mean by continuous mode of operation? Continuous mode of operation matlab your load current is never reaches zero. It's almost like a DC. If in the numerical in the exam, if they ask you load current is ripple free and is almost constant, meaning the load current is something like this. If they mention it is load current or the output current is ripple free, meaning they are telling that the load current is constant. So this is my I out versus omega t, constant there. Now over here, if they mention this, then this is what the scenario is. Now over here, we are assuming like this, almost a DC, right? Correct? If this average value over here is let's say 15 amperes, so ये रहेगा 15.1, नीचे रहेगा 14.9, the variation maximum and minimum, very less. And this continuous mode is possible when the value of L inductor is pretty large. There is one important statement coming up. In case of continuous load current conduction, we don't have to bother about what is happening in the RLE load. The SCRs are triggered the usual way. What is the meaning of it? The SCRs are triggered whenever the gate pulses come. That means your SCR T1 and T2 will conduct in the positive half cycle, and T3 and T4 will conduct in the negative half cycle. So first point is very important. What it means? It means that whatever we have studied for RL load, the waveforms, they are the same. In case of continuous load current. Okay. So, and in case of discontinuous load current, there will be a comparison between V in and E. What is E? The EMF or a battery. If it is a continuous load current, you do not worry about that. But there is one more condition in that. Okay? Did you understand the difference between continuous and discontinuous? Practically, कौन सा use होता है? Do you want your output current to become zero? No. You don't want that. You want a continuous operation. DC motor को चालू बंद नहीं करना है. Once the fan is on, it remains on. So the load current should be continuous. So practically continuous load current cases are considered. Discontinuous we rarely use it, but we have to study it as per a curriculum. Okay? So here it is written one statement. Working of this circuit is similar to working of single phase full wave control rectifier with RL load. We have discussed this thing last time. Is it not? So you can refer this PDF and the page number. That means, abhi batao, this is the same circuit. I mean, these are the waveforms which we have seen. Let us go through them very quickly. Let us revise that, right? So, I have my input. Can you see the colors over there? Okay. So I have my input blue color. It's a sinusoidal waveform, continuous waveform, right? And I marked E. E is a constant, right? Battery, right? Now, let me just expand a little more. Okay. This is it, okay? So I've drawn a dotted line minus V in also, just to show for reference. So over here, whenever V in is less than E, what will happen? What is this E doing in the circuit? It's actually making the job difficult for the thyristors to turn on. वो reverse bias कर रहे हो ना? See, E is against these things, right? It's making this T2, T1 and T2 should conduct in a positive half cycle. ना T2 को negative दिया है. मतलब it's we have to overcome V in minus E voltage for the transistors. I mean SCRs 1 and 2 to conduct. मतलब E is actually opposing the conduction. उसको overcome करना है. So one condition is that this trigger pulses which you apply, it should be in the condition such that V should be greater than E. अगर उसके पहले लगा लिया तो this will happen when the SCRs will get triggered at this point theta 1. Okay, so your delay angle should be delayed further than theta 1. ये requirement है, बाकी सब same है. Are you getting what I'm saying? ये जो alpha है, this alpha should be, this firing angle should be before theta, I mean should be after theta 1. Okay, delay time should be more than that theta 1. Then the operation will be similar. So from 0 to theta 1, is any transistor on? No. I mean any SCR on? No. All the SCRs are off. Correct now? Because this is what is happening. Now V in becomes, I mean all are in reverse blocking mode. Forward blocking bhi nahi hai. All are in reverse blocking. Now theta 1 to alpha. See, T1 and T2 should be in forward blocking, but E is making it reverse blocking. बराबर ना? Now you do V in greater than E. That means this portion of this section, right? Let me highlight it in color. This section. Now you are entering this section, right? So when V in becomes greater than E, the entire operation becomes similar now. Now what happens? T1 and T2 are eligible to turn on, right? Okay, let it be. Yeah. So beyond theta 1 and alpha, your T1 and T2 are forward biased by the supply voltage. T3 and T4 are in reverse blocking mode, and everything is off. So current also will be zero. Current zero होना चाहिए ना, but ये continuous current mode है. इसमें current zero होता ही नहीं है. It continuously flows, flows. So whenever you such kind of a continuous mode operation comes, you start with alpha. अब उसके पहले का पता चल गया ना what happens really, right? Now the condition should be that, did you understand this condition? Did you understand this condition? V should be greater than VE, then only it is conduct, right? Now alpha comes. Which transistors are on? T1 and T2 are on. So whenever T1 and T2 are on, we know the current path direction remains in this direction. A, T1, then we have C, RL load, E, RLE load, D, T2 back to B. This is the current flow. That means whenever T1 and T2 conducts, input is connected to the load via T2 and T1 SCRs. Are you following? So current starts flowing, and input current, source current and the output current have same direction. So let's say that output current, load current is this way. It is continuous, right? So it's rising and then falling down, but never going to zero. So this is what will happen from alpha onwards. From alpha to pi, this is what will happen. What happens beyond alpha? Beyond alpha, V in is going negative, but since value of L is very large, it has a lot of stored energy and is releasing that energy. So that is keeping T1 and T2 on. So T1 and T2 remains on till pi plus alpha. Now as soon as T1 and T2 are on, they become, now T1 and T2 are on currently. Now pi plus alpha has come. So at pi plus alpha, T3 and T4 are turning on. So the turning on of T3 and T4 SERs will turn off T1 and T2. We have discussed this point last time by line commutation. Okay, and then similar entire conduction will, the cycle will repeat. So T1, T3 and T4 will remain on from pi plus alpha to 2 pi plus alpha. Then again T1 and T2 are triggered on. So T3 and T4 will become reverse bias and turn on by natural commutation because entire line commutation aa jata hai. We have discussed this again. So here I have discussed T1, T2 on, T3, T4 on, again T1, T2 and T3, T4. So what happens before alpha? Before alpha में continuity के लिए which SCR should be on? T3 and T4. Correct? अरे ये continuous है ना, तो this period from 0 to alpha T3 and T4 should be on continuity के लिए. Are you getting it? So this is how it will work. And what about why I have drawn the input source current like this? Because only during the positive half cycle when T1 and T2 are forward bias or on, the input current will be equal to output current. But as soon as you go in a negative half cycle, what will be the current direction flow? It will be B, T3, C, RLE load, D, T4 and A. So input current is reversing in direction, but output current is in the same direction. That's why over here I in is in the reverse direction. Nature same hai, but reverse direction mein. Okay. So whenever T3 and T4 are on, I out is equal to minus of I in. And whenever T1 and T2 SCRs are on, I in is equal to I out. Simple. Okay. Now, what about voltage across the transistors T1 and T2? Remember one thing. Whenever SCRs T1 and T2 are on, the voltage across them is 0. Whenever they are off, it's equal to V. Whenever SCRs T3 and T4 are on, their voltage across them is 0. But when they are off, the voltage across them is equal to minus V. Right? So here is the situation. So in the first case, 0 to alpha, your T1 and T2 are off. So it will follow V. This blue color is my V dotted line, right? And then from the period alpha to pi plus alpha, T1 and T2 are conducting. So remain off, 0. Then again they are off from pi plus alpha to 2 pi plus alpha. So it will follow V and it will repeat. Understood? What about voltage across the SCR T3 and T4? 0 to alpha, T3 and T4 are on, right? So 0. Then they are off from alpha to pi plus alpha. Off matlab they will follow minus V. So they are following minus V. That is why we have to draw minus V in ka dotted line. Okay. And again from pi plus alpha to 2 pi plus alpha, T3 and T4 are on. So the voltage across them will be 0. Right? So this is how the continuous mode of operation will, happen. And this is for alpha less than 90. What do you mean by alpha less than 90? ये 90 degree है peak. उसके पहले है ना, so that is less than 90. There is an operation alpha greater than 90 also. Are you following? Now, I'll tell you something which I have not told you so far. So there is a quadrant of operation. Okay, there is something called as quadrant of operation. So here let's say we have output current and here you have output voltage. So in this case for alpha less than 90 degrees, is my input, what is my average value of output, positive or negative? अरे average क्या दिख रहा है? Positive peak is higher ना? So average value of V out is what? Positive. What about my output current? Positive. So matlab both are positive, we are in this triangle. Correct? Both I out and V out are positive now. So that means power I out into V out is also positive. Meaning power is being transferred from source to load. and it works as a control rectifier. समझ में आई बात? Right? So yeah, so you have to write, or I mean, you want to write something? Yeah. So also you can observe this. V in. See, during the positive half cycle, V in is positive, right? Let's say from 0 to alpha, V in is positive. What about I in? It's negative, na? V in is positive, I in is negative. What about alpha to pi? Let's say alpha to pi, V in is positive, major positive. What about I in? Major positive. So that means the power flow, the input power flow. देखो इधर, V in and I in are positive from alpha to pi, correct? Whereas V in is positive, but I in is negative from 0 to alpha. Matlab, if I want to calculate input power, that is V in into I in is positive from pi to alpha. Yes, na? Whereas P in is negative from 0 to alpha. ये देखो बराबर ना? V in is negative from 0 to alpha, meaning what? What is P in? Net instantaneous power supplied by the source is negative. Okay, from that period. Now, whenever alpha is less than 90, what is pi minus alpha? What is pi minus alpha over here? Can you tell me what is pi minus alpha? This is 0 to alpha and this is pi. What is pi minus alpha? This minus this portion. ये वाला portion ना? Correct? This is what pi. इसे को ये पूरा pi है, 0 to pi, then 0 to alpha. So this is pi minus alpha, right? ये मेरा pi minus alpha, is it greater than alpha? This is alpha, इधर से इधर तक. Correct now? So is my pi minus alpha greater than alpha? Yes. So whenever my pi minus alpha is greater than alpha, my average input power is positive. That means my source is supplying the power to the load. It acts as a control rectifier. And this happens for alpha less than 90 degrees. Okay, you have drawn the circuit diagram. Write this down. You have understood pi minus alpha? It's a bigger portion compared to alpha. Alpha greater than 90 degree में उल्टा रहेगा. हाँ. Which graph? I mean, voltage across the. इस केस में RLE load, what is the statement written over here? वो V माइनस ही कब होता है? जब भी लोड करंट जीरो जाता है. Are you getting what I'm saying? तो यहाँ पे क्या लिखा है? In case of continuous load current, we don't have to bother about what is happening in the RLE load. This should clarify that point. मतलब RLE load हो continuous current mode में दोनों waveform same है. Your doubt will come when we discuss discontinuous. हम लोग ने मुझे पता कहाँ से आ रहा है. We have discussed half wave control rectifier with RLE load. उसमें voltage across the SCR was V in minus E, right? वही डाउट है ना तुम्हें? हाँ, that will RLE load in continuous mode operation, it doesn't depend upon RLE load at all. It's just operating. Only thing is, only one precaution you have to take. Alpha should fire after theta 1. That's it. कुछ भी नहीं. Nothing. See. अच्छा सुनो, आइडियली स्पीकिंग क्या होना चाहिए? V is falling below E, so SCR हमारे रिवर्स बायस होने चाहिए. बट L के पास इतनी पावर है, इतना स्टोर्ड एनर्जी है, इट विल कंटिन्यू टू अलाउ दैट. समझ में आया क्या बोल रहा हूँ? सी L हैज लेट्स से 5000 लीटर टैंक, 500 बार निकला तो कितना बचा? plenty of energy is there which it can release. Doubt clear? Negative half cycle में why does the SCR turn on? Continue to remain on because of the inductor. अभी तो inductor very large है, continuous current very large. अगर very very large inductor है क्या होगा मेरा source current? See this is my I out current, right? So when I say ऐसे मेरा source current दिखेगा. So if this is my output current, this is my output current. How will be my input current? Square wave होगा. समझ में? What I am saying? अगर ये straight line हुआ I out, this IN will be like a square wave. But load current waveform will remain same. Okay? Are you understanding? This only happens when load current is continuous. That will be, that is coming because of discontinuous mode of current. हम लोगों ने discontinuous discuss किया था. Is it clear? So write this down. Next, we will draw the waveforms for alpha greater than 90 degree. That you have to draw on your books. Alpha less than 90 degree was similar to RL load wala, continuous mode. But less than greater than 90 degree you have to draw on your own. Written and draw this small little indicating that P in is positive, right? I mean P out is positive or power is positive. Here we can call it controlled rectifier. Okay, I hope you are understanding the context. It will behave as a controlled rectifier. That means it will convert AC to DC. AC to average DC, right? Pure DC नहीं होता यहाँ पे. But that average value we can control by controlling the firing angle. समझ गया? Okay. Now write down the V out average formula. ये derive किया हुआ है हम लोग ने. Derivation is same. Exactly the same. So write down V out average formula. 2 Vm by pi cos alpha. V out average is 2 Vm by pi cos alpha. You can derive this on your own. So either you can have the interval going from 0 to pi or from alpha to pi plus alpha. It means the same. एक period ही है ना. Okay. अभी देखो ध्यान से देखो. If alpha in that cos alpha is less than 90 degree, V out average will be positive. Because let's say alpha is 45 degree, Vm is 100. So what will be V out average? 2 into 100 upon pi into cos 45. That will be 45.02 volt. You can check it out in the calculator. Okay. 200 upon pi into 45 degrees, cos 45 degrees. But when V out is greater than 90 degree, your average value of the output will be negative. From the formula only, na? So in this case, if alpha is let's say 135 degree and your Vm is 100, so 2 into 100, 200 divided by pi into cos 135 will be minus 45.02 volt. You can check it out. Yeah. So this is a very very crucial point. Now V out RMS, write down the formula. This also we have derived. You remember for RL load we have done the derivations. V out RMS is Vm by root 2. For what? For single phase full wave control rectifier with RL load continuous mode and RLE load continuous mode. दोनों के लिए same है. For alpha less than 90. Yeah? Okay. Now the circuit turn off time. TC is 2 pi minus pi plus alpha upon omega. That will be pi minus alpha upon omega. So this formulas will come in handy while we solve numericals. Completed. Next, PIV rating. PIV rating for a full wave bridge rectifier is VM. You remember, anyone remembers for a center tap full wave rectifier it has 2 VM. But in case of bridge rectifier it is VM. Okay, so note it down. ये लिखा हुआ यहाँ पे firing angle must be greater than theta 1. I have already discussed that point, right? Next, I out average. I out average is V out average upon R. अभी ऐसा क्यों है? Why do you say ऐसे है? RLE लोड है ना, तो R क्यों है? वो तो बैटरी है, E है, right? What about L? Average current flowing through the inductor is constant. वो zero, actually constant. So that's why we have written it like this. Through the inductor. Okay? So that's why you write it, it will be V out average upon R, that's it. Same is the case for I out RMS. V out RMS upon R. ठीक है? Written? Power factor. Power factor is average output power upon apparent input power, right? Now what is the average output power? See, average power consumed by the inductor will be 0. ऐसे because current is constant, let's say average current is also 0 there. So L di by dt ना, voltage across the inductor. अगर I constant है तो di by dt will be 0. तो voltage is 0, voltage 0 to power 0. So average power consumed by inductor is 0. But RLE load है ना, E तो है ना. So whenever you connect a battery, that battery gets charged. RLE load में अगर E लगाओगे, अगर RL load है and you add a battery, the battery gets charged. So वो battery कैसे charge होता है? E into I out average. So average output power will be I square R, right? If it is a RL load, I mean if it is a R load or RL load. But if it is a RLE load, the E component also will come. So it will be E into I out average. So write down this formula. Or apparent input power is V in RMS into I in RMS. See, current starts flowing through the battery charges. Okay? वही है ना फंडा. You turn on the electricity, you supply the current ना, battery gets charged. तो इधर भी तो वही हो रहा है. Okay? Now, there is one point written over here. If alpha is greater than 90 degree, then the output power is negative. We will come back to this point. अभी क्या करना क्या है? There is requirement. What is the requirement? सुनो, अभी ध्यान से सुनो. Here what was happening? The power was positive. See, हम लोग we cannot make, actually current will remain on the positive side. Yeah, voltage can go negative. यहाँ पे जरा एक्सिस जरा चेंज करो. I out will remain positive, but voltage can go negative. So this is for alpha greater than 90 degree, and it doesn't work as a rectifier, it works as an inverter. What is inverter? Opposite of rectifier. Rectifier is AC to DC. This is मतलब power should flow from load to the source. तभी वो inverter कहलाएगा. मतलब in how this circuit becomes an inverter. It's name written there. Single phase line commutated inverter. Whenever under two conditions, alpha होना चाहिए greater than 90 degree, and this battery should be reversed or it should be negative. Then your power will flow from source from load to source. मतलब ये हमारा इनपुट की तरह काम करेगा. That will become my output. ऐसे होगा, opposite होगा. So then the same circuit will act as an inverter, line commutated inverter. Okay, so what are the two conditions? Alpha greater than 90 degree and E is negative. Okay, write down these two conditions. Write down the name line commutated inverter. Alpha greater than 90, E is negative. And power triangle बनाया ये वाला. V out is negative, I out is always positive, right? Right hand side है ना I out. So the same circuit will act as an inverter. The working remains the same. खाली alpha equal to greater than 90 degree के लिए waveforms बनाओ. Now try to draw the waveforms on your own first. Start. First draw V in, then Ig1, Ig2, Ig3, Ig4, then output voltage, V out, then output current, input current, and you can also draw voltage across the SCRs. What are the two conditions? Alpha greater than 90. So मेरा average output value will be 0, right? We have seen with an example. And E is negative. Under those conditions, the same circuit will behave as a line commutated inverter. So we have to draw the waveforms. Let me just check if I have a spare one. Okay, this was for 11B. We were supposed to cover in lecture number 11, but it's fine. So I have to change it again. This is for lecture number 12, and this is for RLE load, right? Only continuous mode of operation. तो पहले current कैसे होगा मेरा? How will the current will be? You draw it on your own. Draw करो. This is the circuit. My E will be negative, huh? Okay, here there is one thing. Here it is drawn for alpha only greater less than 90, ना? I don't have that sample. इस केस में सारे के सारे इधर शिफ्ट हो जाएंगे right hand side में. This will be shifted towards here. So this will be like, let me see if I can draw that. ऐसे हो जाएगा. Okay? Not this. It will be really difficult for me to draw that here because all are referenced with respect to alpha less than 90 degree. So you try to draw on your own. ये सब dotted lines is for alpha less than 90 degree. So please recollect and draw on your own. So we also will try simultaneously over here. At least till load voltage. Okay. So we have our V in over here. 0, pi, 2 pi, 3 pi, omega t. This is my V. And where is my E? Below, right? Correct now? E negative है ना? For a line commutated inverter, this is negative. Now next what you will do? Gate pulses, right? How will you apply the gate pulses? Okay, just started misbehaving again. Now tell me. Yes, the pulses I am drawing, let's say with this color, a little dark. मे बी हियर, और ये सेम नहीं है, नेक्स्ट में कलर चेंज होगा. व्हाई? बिकॉज वी आर अप्लाइंग फॉर डिफरेंट. Then you will have it here. Correct? Please draw. This will be alpha, pi plus alpha, 2 pi plus alpha. Next, I will draw V out. I mean, I out also, I mean, we should ideally draw I out first. So, for I out, we have to do that, referencing. Okay, sorry. Yeah, from here. Okay, so better to have a scale over here and then do the. Okay, fine. So how will my output current, I mean, the output current will look like? What will be the assumption? It's a constant, right? Last time कैसे था वो? You remember? हाँ. तो यहाँ पे कैसे होगा? You always start from here, right? How will you start? Increasing or decreasing? देखो, इधर पॉजिटिव जा रहा था, उधर नेगेटिव जा रहा होगा. तो फॉल लंबा होगा. Right? So how it will be? ठीक है? यहाँ पे फाइन. या समझ में आ रहा है what I'm drawing? Yeah. Now next is V out. So V out, I have to do this referencing again. Okay. This is pi plus. So this is my alpha pi, pi plus alpha, 2 pi plus alpha, right? And that's my load current. How will be my waveform? First of all, I have to draw that dotted line one, right? Are you able to see this color? It should not be displayed. Examiner के लिए नहीं है वो, तुम्हारे लिए है. Why you are drawing this dotted lines for your reference? ताकि तुम बराबर से बना सको. तो very light. It should be visible only to you. So now how will you draw the waveforms now? I am drawing in red color. कैसे start करोगे? Always start from alpha, right? तो यहाँ से यहाँ तक my T1 and T2 are on, right? From here to here. On matlab it will follow what? Output. Correct, up till here. Then what happens after pi plus alpha? T3 and T4 are on. So again same thing will happen. It will follow V in, right? Same thing will happen over here. And यहाँ पे क्या होगा? उसके पहले वाला. What will happen? नीचे वाला V फॉलो करेगा. हाँ. Why? V out will be equal to V in when T1, T2 are on. V out will be equal to minus V in when T3 T4 are on. बराबर है? So इसमें एवरेज वैल्यू देख के ही लग रहा है ना, V out average is negative. और मेरा सोर्स करंट कैसे रहेगा, मतलब हाउ विल बी माय इनपुट करंट? If I have my input current over here, how it will be? Whenever T1 and T2 are on, IN will be equal to same, right? IN will be equal to I out, right? So it will be same over here also. Correct? And whenever T3, T4 are on, it will be, yes, na? VT. हाँ? E का इफेक्ट ही नहीं है, कंटिन्यूस करंट है. E का इफेक्ट कभी हटा है बिकॉज करंट बिकम जीरो. यहाँ पे करंट जीरो ही नहीं हो रहा है. दिस यू आर फॉलोइंग? So this will be IN. And then voltage across the thyristors you can draw on your own. Yeah? Agar in this case, if let's consider an example, अगर ऐसे होता, सुनो एक मिनट, everyone pay attention. अगर मेरा लोड करंट कांस्टेंट होता, let's say my load current instead of this it would have been constant, what would have been the difference? If I out is constant, what would have been the difference? मतलब कोई रिपल नहीं है, फ्लक्चुएशंस नहीं है, राइट? So what would have been the difference? Tell me fast. Will it make a difference to this V out? No. V out will remain same as this. Correct? What about I in? I in में इधर बनाओ. See, I'm teaching two things in one now. Let me represent. यहाँ पे अल्फा है मेरा, करेक्ट? यहाँ पे पाई प्लस अल्फा है, एंड यहाँ पे व्हाट इज इट? ठीक है? So this representation I'll keep it down. हाँ, अभी बताओ कैसे होगा वेवफॉर्म? How it will be? It will be, I told you, it will be like a square wave. I mean, square wave, right? ऐसे होगा. Are you following what I'm saying? Voltage, load voltage में फर्क नहीं पड़ेगा. Your input current waveforms, source current is getting distorted. It's becoming a square wave. तो इसमें कैसे बन गया ये? हार्मोनिक्स आ गया. So if you apply a load current constant, your source input current waveforms will look like this. So it is only possible due to this. Only then the waveforms will look like this. Whereas V out waveform will be same as this. Are you understanding? If you correctly draw the waveforms for any controlled rectifier circuit, you'll never go wrong in explanation also, because you have the waveforms. So just the circuit diagram correctly, the waveforms correctly, reference line properly, and all, and you can easily attain working and all. Derivations are very simple. Completed? ये मैंने नोट्स में नहीं लिखा है, ये वाला बताया नहीं है. Whenever load current is constant, ये normally numericals में आता है. Assume that the output load current is constant and your source current waveform will become a square wave. बराबर ना? Concept समझ ऐड करने जाओगे तो you will definitely make a mistake. Okay? Can we go on to this? Yeah, this line commutator inverters are generally used in regenerative braking of a DC motor. So you'll learn about regenerative braking. Must be you must have learned it, already heard it. DC motors also require braking, and where E is the counter EMF of the DC motor, right? देखो क्या लिखा है, working is similar to case alpha less than 90, but following are the differences. Alpha greater than 90 या E negative. I cannot write the working ना, ऐसे लिख के नहीं आना एग्जाम में. एग्जाम में you have to explain the working ना. ये लिख के आ जाओगे भाई, भरोसा नहीं है. Students will write it. फिर बोलेंगे सर you have written this way, we have also written this way. Okay. So these are the differences. Alpha greater than 90, E is negative, and V out average is negative. These points are clear. तो यहाँ पे my output average output power, यहाँ पे क्या हो गया देखो, what is pi minus alpha over here? Pi minus alpha बताओ, ऐसे ही है ना वेव फॉर्म्स, यही ड्रॉ किए थे ना, सेम है ना, this only we have drawn, right? With more colors variety. That's the only difference. हाँ, अब इसमें बताओ, from 0 to pi, what is pi minus alpha over here? Pi minus alpha is this, right? This is pi minus alpha. और ये क्या है? Alpha. Which is greater? Alpha is greater. Right? So that means my Pin is negative. मतलब positive part छोटा है, negative part बहुत बड़ा है. So my input power is negative. ठीक है? Similarly, my output power is also negative. यहाँ पे क्या लिखा है, नेट एवरेज आउटपुट पावर, ये पॉजिटिव कभी है, ओनली ड्यूरिंग अल्फा टू पाई, और अल्फा टू पाई छोटा सा पार्ट है ना, फ्रॉम 0 टू अल्फा में पी आउट एवरेज इज नेगेटिव. देख लो इधर, तो विच पोर्शन इज ग्रेटर, पी आउट एवरेज नेगेटिव पोर्शन इज ग्रेटर, बराबर ना, ड्यूरिंग दैट पीरियड, ड्यूरिंग 0 टू अल्फा, राइट. सो दैट मीन्स एवरेज आउटपुट पावर इज नेगेटिव. पावर नेगेटिव का मतलब क्या हुआ, the power is flowing back from load to the source, right? And that's the meaning of this power triangle. Power triangle किधर गया, हाँ ये वाला. Then it is acting as an inverter. Are you getting the point? Yeah. Yeah, these are the inverter conditions. Your E should be negative, which will aid in keeping I out positive. अगर V in को negative नहीं किया तो I out positive नहीं रहेगा, and that will disrupt the working of an inverter. I out continuous in one direction only, constant चाहिए. See, I out को constant करने के लिए बहुत सारे circuits हैं, and this is one of them. Derivation same, write down the formula. पर इस केस में हम लोग ने क्या किया है, अल्फा टू पाई प्लस अल्फा गए, दैट ऑल्सो वी कैन डू ना, डिफरेंस इज व्हाट, टी वही टी है. सो वी आउट एवरेजेस 2 Vm अपॉन पाई कॉस अल्फा. अरे सॉरी, देयर इज वन मिस्टेक. मिस्टेक नहीं है, तुम्हारे लिए मिस्टेक नहीं है, दिस इज ग्रेटर, बराबर. लेट मी सेव इट. वी आउट एवरेजेस 2 Vm अपॉन पाई कॉस अल्फा, सेम है ना, सेम एज अल्फा लेस देन 90 डिग्री ऑल्सो. वो चेंज क्या होगा, अल्फा, अल्फा में मेक द एवरेज वोल्टेज नेगेटिव और पॉजिटिव, बराबर. बाकी Vm इन पाई टू फिक्स है ना. तो ये डेरिवेशन है, देख लो, ये इजी है. दिस अल्फा टू पाई प्लस अल्फा डेरिवेशन इज इजी. I hope that I can skip that part explaining the derivation. You can manage on your own. Okay, इसमें गए तो फिर हो गया. फिर you have written the derivation, I mean written the final formula. V out RMS is Vm by root 2. In the exam, if they ask the derivation, do it this way. देखो, alpha to pi plus alpha. So in 1 or 2 steps it नहीं, for 4 or 5 steps it comes. ये सब करने के बाद मिलता है Vm by root 2. Very very important derivations. Written. So again I have gone from alpha to pi plus alpha. You should know trigonometric relation. That is sin square alpha is equal to 1 minus cos 2 theta. I mean cos 2 alpha by 2. Then you should also know the relation sin of a plus b is sin a cos b minus cos a sin b. ऐसे कुछ है ना? इसमें भी थोड़ा सा मिस्टेक है. This is cos, right? हाँ, अभी भी ठीक है. Write down the numerical fast. Quickly. This numerical and that's it then. A single phase fully controlled converter is connected to RLE load or diode. Is connected to RLE load. The source voltage is 230 volt 50 hertz. What is this? Vm or V in RMS? Ah. No, it's V in RMS. Load current, देखो अभी इधर. Load, ये देखो statement. Load current of constant magnitude of 15 amperes. मतलब क्या? They are saying I out is constant of 15 amperes. बराबर है? अगर मेरा load current constant है, again my V out formula will not change. It will remain the same only, right? The load current is constant, मतलब I out is 15 amperes. For R equal to 0.5 ohms and L equal to 3 millihenry, compute the firing angle to operate as converter and inverter when E is magnitude of E is 130. मतलब we have to calculate. We know alpha less than 90 it will work as a converter. Alpha greater than 90 it will work as an inverter. ये पूछ रहे exact बताओ. Under these conditions, tell me exactly what is alpha. समझ गया? बहुत easy है ये. It's not at all hard. Okay. Can we start? Did you have written the numerical? So let us write down what is given. V in RMS is given 230 volt. Magnitude of E is 130. R is 0.5. L is 3 milliamperes. I out is 15 amperes constant current. I hope you understand what do you mean by constant current now. So for the converter, what is the formula? What is the formula? 2 Vm by pi cos alpha, right? But यहाँ पे और एक formula है V out average का. ये कैसे आया? E plus I out into R. देखो RLE load है ना? See here. And then you have converters and all. I am not drawing that. ये वाले converter circuit है. हमारा ये output है, right? Current is flowing, right? ठीक है? अगर मेरा current flow हो रहा है इसमें, what will be my VR voltage? I mean I into R, right? What will be the voltage across the inductor? कैसे? Current क्या है? Constant ना? Constant का differentiation क्या रहता है? हाँ, देखो L di by dt. उन्होंने क्या बोला है numerical में? What they have said, I is constant, right? If I is constant, di by dt will become 0. Are you following? बराबर ना? So V out will be IR plus E. Any doubts? That's why we have this formula. I out into R plus E. Correct? लिखो. ये formula we have derived 2 Vm upon pi cos alpha. but this formula we got it from the circuit. ये RLE लोड ही है. I hope you are not confused कि L किधर गया. Almost constant ना, so that's why VL is 0. Okay, now what are we supposed to find out? Alpha, right? So we have the formula for VM. VM is 230 root 2, 2 times RMS, and E is given to us how much? 130. I out is given 15. R is given 0.5. So calculate alpha fast. Don't write directly. Please calculate alpha. So alpha will come out to be 48.39, less than 90, right? The clue is it should be less than 90. Please don't believe in this answer. Verify yourself. It's a very, very important numerical. Understand the concept of converter and inverter for alpha greater than less than 90. So please calculate and let me know if you're getting 48.39 degrees. Any results? Alpha? Calculated yourself. So till the time, just confirm fast. What is alpha called as current? Sorry? 53. Just one more person, please calculate this and tell. Okay. One of you, please cross check it. That's what I told you. Cross check this answer. Check. Okay. Now listen. Complete नहीं हुआ है. To sort it out. Complete नहीं हुआ है. Now inverter के लिए what is E? Condition क्या होता है? Negative होना चाहिए ना? E should be 1 minus 130. Formula is same, right? तो खाली E minus 130 substitute करो and again calculate alpha. It will come greater than 90. ठीक है? Just इतना simple. It's a fundamental numerical. So when E is 130 minus 130, recalculate alpha, which is the firing angle. The clue is it should be greater than 90 degrees. कितना आ रहा है? Is it 126? 126 degrees. Okay, very good. Okay. So now we will take a break, and after the break, we will discuss the single phase full wave control rectifier with discontinuous load current. ठीक है? The doubt you were asking ना, E minus E इसमें आएगा. I'll just show you the this also read this till then. The term discontinuous is applied to the condition when load current reaches to zero during each half cycle before the next SCRS sequence is fired. Remember, this is not recommended for practical cases. Load performance deteriorates if load current becomes discontinuous. Therefore, it is always preferable to operate a DC load with continuous current. और ये I'll quickly show you the waveforms. यही है ना, ऐसे आएगा ना. Only discontinuous की वजह से now the E will become comparable. Now that RLE load will come into only discontinuous current. ठीक है? So this we will discuss after the break, and also there is a topic called these two things will be covered from 115 to